Uh, Good morning, all. In today's session, let us continue the problems which we were dealing on Module 1. In the previous session, we have already seen some of the problems on Coulomb's law. Now, in today's session, let us see the problems based on electric field intensity. How to find the electric field intensity. Let us take the first problem. 2 point charges. The one charge is 3 nanocoulomb, the other charge is minus 2 nanocoulomb. One is positive, one is negative. They are spaced 2 meters apart. So the distance between them is given as 2 meters. Determine the electric field intensity at some point, and this point is 1 meters from each of these two charges. Okay. Uh, According to the given question, let us try finding the solution. Very first thing, we will list the data. According to the given question, two charges are given. So let us denote one charge as Q1, the other charge as Q2. So list those two. Then, now, second step is it possible to represent this given question in the form of a diagram? Let us see. Two charges are there and they are spaced 2 meters apart. So let me take one point, say P1, the other point P2, and the Q1 and Q2 are placed at points P1 and P2. And the distance between them, the spacing between Q1 and Q2 is 2 meters. It is given already. Now, where to find the electric field intensity? So we should have a point, that is a point. This point is such that it is 1 meter from each of this. So if I take this exactly at the center, it is 1 meter from Q1 and 1 meter from Q2, so that the total distance is 2 meters. Okay, this is how we can represent the given question in the form of a diagram. So point is here. Here we need to find the electric field intensity. We have already seen in the previous session while solving the problems on force, if there are two or more number of charges exists, the total net force, the resultant force is sum of individual forces. So the same concept applies here also. We have two charges, Q1 and Q2. So obviously we'll be having two field intensities, E1 and E2. So what is net field? Net field will be sum of E1 and E2. So let us start with the first one. We will try to calculate the electric field intensity E1 at point P due to the charge Q1. This is one. And similarly, we will find the electric field intensity E2 at point P due to the charge Q2. So there are two aspects here, E1 and E2. Let's try with the E1 first. So we need to find the electric field intensity. Before further proceeding towards the problem, it is very important we should find the unit vector's direction. For this particular part I am talking. Q1 given is 3 nanocoulomb. It is a positive charge. So according to the conventions used, the field lines, they diverge from the positive charge, right? This is the point. They go out like this. In all directions, it will go like this. So this is the convention used. According to that, if I take, this will be the direction of the unit vector, say AR1. R1 indicates this, distance is R. 1 is for charge Q1 and A is your unit vector A cap. Okay. So now we have seen this is the direction of unit vector for first charge for the electric field intensity E1. The same thing I have written here. Since Q1 is positive, so the field diverges from P1. From P1, it will diverge. It will go like that. And the direction of unit vector, it will be from P1 to P. Okay, the direction is from P1 to P. So we know that the electric field intensity E1 is given by 1 by 4 pi epsilon naught. Charge Q by the distance square. Charge is actually Q1 for E1. Q1 divided by R1 square. R1 indicates the distance between the charge q1 and the point, which is 1 meter, into AR1 cap unit vector. So what I'll do, I'll keep this same. Before proceeding for that, let me just explain you this unit vector. Generally, how we represent unit vector is the position vector, whatever we get, the position vector divided by its magnitude. This is how we calculate the unit vector. We have seen in many of the previous problems, we have calculated in the same way. Now, this numerator will have AX, AY and AZ. Three different terms will exist. But if you see the question, in the question, there is only 2 meter, 1 meter specified, and that too only one axis. Actually, three-dimensional coordinate system has three axes, X, Y and Z. But according to the given diagram, what we have drawn, Q1 and Q2, there is only a single line indicating there is only that too, the spacing, the distance is given only one value. Okay, you can see it here in the previous problem. Whenever the distances are mentioned, the distances are mentioned in the form of points with these distances, the values. What do you mean by P1 of 1, 2, 3? It means you have a three-dimensional system, X, Y and Z. This is the coordinate system. 1 indicates X direction. You come here, 1. 2 indicates Y direction. You travel 2 meters. This is 1 meter. This is 2 meter. You come here. 3 indicates Z direction. You go up 3 meter. You will come here. This is your point P1. This is the meaning. So, point has three terms, X, Y and Z. But however, if you check here, in your given question, there is only one value mentioned, 2 meter and 1 meter. What do you mean by this? Out of three axes, X, Y and Z, only one axis exists. So if I, in a simpler fashion, when you are using the graph sheet, you draw like this, okay? First quadrant, second, third and fourth, and horizontal axis represents X, vertical represents Y. So very simplest form of representation of a two-dimensional graph. So horizontal axis represents X. That's why when I elaborate your AR1, it will be only in X direction. I am taking horizontal as AX. But if you want to consider this coordinate system with this as X, this as Y and this as Z, the horizontal axis will be Y. In that case, your unit vector will be AY. But however, it is better to go for a simple two-dimensional X and Y, wherein this represents your X direction. So if I choose like that, unit vector will be, the AR1, it will be AX. That's it. No AY, no AZ, because only 2 meters, only one distance is specified. Okay. So I have written it here, AX. Remaining is 1 by 4 pi epsilon naught. Write the values. Charge Q is given to you. Sorry, Q1. Q1 is 3 nanocoulombs. And the spacing, the distance between the point and the Q1. What is that? Distance between point and the Q1, it is 1 meters. So 1 square. So you can use your calculator, put this in the numerator 3 and 10's powers, 9 powers gets cancelled. Here you will be left with 10 raised to minus 3. So take the calculator, 3 divided by 4 pi, 8.854 into 10 to the power of minus 3. If you calculate all, you will get 26.963 AX. Keep it as it is, AX. This is about this particular field, that is E1. Similarly, we should go for one more field, that is E2. How to find E2? The same manner. Before proceeding for the formula, we will try to identify the unit vector direction. Given charge Q2 is negative, okay, according to the conventions, all the field lines for the negative charge, they will come and they converge. It should be like this. Convention, rule, according to the convention, they converge. So if I consider that, this will be your direction of the unit vector for second field, AR2 cap. Okay, for charge q2. So if this is the direction, so let's see, charge q2 is negative, so field converges on p2, and the direction of unit vector will be from p to p suffix 2. So the direction is from p to p suffix 2, and again it is ax only because only one distance, 1 meter. Okay. So formula is E2 equals to 1 by 4 pi epsilon naught charge divided by the distance square. Charge, you can take it Q2. Q2 by R2 square into AR2. 1 by 4 pi epsilon naught, constant values are there, put it. Q2 is given to you, 2 into 10 to the power of minus 9. Negative sign I have not considered because negative sign already I have taken it in this direction part. Okay, just to know the direction I have utilized. But if I take only magnitude, you calculate, you can take either consider 2 or not. If I don't consider, it will be simply take numerator 2 divided by 4 pi epsilon naught 10 to the raised to minus 3 into ax. So you'll get somewhat 17.975. If you consider negative sign, it will be minus 17. Okay. Now, what is the total field? The total field E will be sum of E1 and E2. So, if you take a negative direction, this will get subtracted. That's the difference. I have not considered, I have taken only positive. But if you take the negative sign, E2 will be minus 17. Under that condition, the total field will be 26 minus 17, somewhat around, you will get some, how much? 12, 11, something. You will get that. Okay, this is how we calculate the field. Let us take one more problem of similar kind. Find the electric field at the origin. So point is given, the point is origin, due to a charge, and a charge magnitude is given 6.44. It is a positive charge which is located at the point. So here 1 meter, 2 meter distance is not given. 3 different directions are given, 4, 2 and minus 3. It means unit vector has got all the 3 directions. So can I represent this in the form of a diagram? First list the data. Charge is given to you, which is positive value. Now there is one origin point. Here the coordinates are 0, 0, 0 obviously. And there is a charge at point 4, 2 and minus 3 meters. So 4, 2, minus 3 is the point given for the charge, where the charge is kept. आपके classroom में एक corner को consider करो, that corner acts as the origin. Okay, one edge. I can show you like this. This is your classroom. Okay. If this is your classroom, if I consider this corner, this as the origin point, okay, and say यहाँ पर एक point P है, and वो point वो दिए हैं already, it is 4, 2 and minus 3. Point is given to you. This is the corner, it is the origin. So we need to find the field at this corner. What is the field, electric field intensity due to this charge Q which is at point P? This is how the question is. Same thing I have represented, origin, point, charge is kept here. Now, can I find the direction of the unit vector? Yes, let's start that. Charge is positive. Charge positive hai, it means according to the convention, for any positive charge, the field lines, they will diverge, they go out. Okay, like that. If I consider this is the charge Q, this will be the direction, they go out, right? They go out. So this will be the direction of the unit vector. So it is AR. Now, and R I have shown here the distance between the point and the origin, and how to calculate this distance, you know how to find using distance formula. 2 points are given to you, use the points, take the distance formula and calculate the small r. Now, we know that the electric field intensity E is given by 1 by 4 pi epsilon naught Q by R square into AR. In this, all these values are known to you, 4 pi and epsilon naught. This charge is also given to you. Remaining is these 2 points. R and AR. So we need to calculate them. So let's start with that. Now the distance R from O to P, as I have told you, use the distance formula. R is equal to square root of, okay, R is equal to square root of this minus this, x direction, y direction, z direction. 0 minus 4 square, 0 minus 2 square, 0 minus of minus 3 square. So either you take either 0 minus 4 or 4 minus 0, doesn't matter. The power is even, so negative sign will not count. So you will get square root of 4 square plus 2 square plus 3 square root of 29, which comes up to around 5.39 meters. So distance we have calculated. So in the formula, this is over. Now let's calculate the AR. Now I'll give you a simple trick to get this bracket values easily. You can see here the arrow mark is like this. Okay, what I'll do, I'll take this as the initial value, and this arrow mark where this arrowhead is there, I will take this as final value. So how to find the point? It will be final value minus initial value. Okay, similarly अगर आपका यूनिट वेक्टर इस डायरेक्शन में है तो ये जो पॉइंट है स्टार्टिंग पॉइंट उसको इनिशियल वैल्यू लो, ये जो एरो मार्क है, एरो हेड है, उसको आप फाइनल वैल्यू लो. सो हाउ कैन यू सब्ट्रैक्ट? इट विल बी फाइनल वैल्यू माइनस इनिशियल वैल्यू. ओके, ये ट्रिक शॉर्टकट है आपको याद रखने के लिए. रिमेंबर दिस व्हाइल सब्ट्रैक्टिंग, because many times you may get the confusion even in case of force also. When we are deciding, if you see this is your q1 and q2, what we have done, we have taken one origin point, then we have dragged the lines, then according to the charges, whether q1 and q2 positive or negative, we will decide these directions either in this way or in this way. Then we apply vector addition, then we will decide whether it is r1 minus r2 or r2 minus r1. Instead of going to that, you can do this. Just take the arrow, where it starts it is I, where it ends the arrow it is F. So take F minus I. Okay, if I do that, let's try that. Okay, if I do that, arrow is in this manner. So ये आपका ये point, ये end point, ये initial value है, and ये जो point है final value है. So what we need to do? Final value minus initial value. Final value ये है 0 0 0, initial value 4 2 and minus 3 है. So F minus I means 0 minus 4, 0 minus 2, 0 minus of minus 3. The same thing I have written here. You can observe 0 minus 4 into AX, 0 minus 2 into AY, 0 minus of minus 3 into AZ. So it is a simpler trick to remember. डायरेक्शन अगर ऐसे है तो ये I होगा, ये F होगा, F माइनस I कर दो. डायरेक्शन ऐसे है तो take this initial, take this final. Okay, these points actually indicate these end points. Okay, towards that. ये एरो मार्क ऐसे है, इसका मतलब ये आपका इनिशियल वैल्यू है. इट मीन्स ये एंड में जो पॉइंट एग्जिस्ट करेगा वो इनिशियल वैल्यू होगा, एंड ये एरो मार्क के एंड पे जो पॉइंट एग्जिस्ट करेगा वो आपका फाइनल वैल्यू होगा. एफ माइनस आई कर देना है बस. So if I do that, this will be the numerator divided by, just now we have seen what is the magnitude of that r. Magnitude of this is 4 square, 2 square, 3 square, square root. So root of 29, which is 5.39. Put that as it is. Then solve it. Solve it. Minus 4, this will be minus 4, this will be minus 2, and this will be plus 3. Divided by this, if you just take the ratio 4 by 5.39, 2 by 5.39, 3 by 5.39, you will get 0.74, 0.37, 0.56. So we have calculated R and AR both. Now we can find the electric field. So electric field intensity is given by 1 by 4 pi epsilon naught charge Q divided by R square into AR. 1 by 4 pi epsilon naught charge is given 6.44 positive value. distance square, 5.39 square. Just now we have calculated it. You can see 5.39 is the distance. So take that square, distance square into AR. Let me keep it as it is. Once I calculate all this from the calculator, I will get some number. I will multiply that number with the AR. If I calculate, I'll get 1.9958, approximately 2 AR. So after this, once I get this, now write the AR. Just now we have calculated what is AR. Okay, what is AR? This much. The same thing I have written here, AR. And finally, you multiply this with all the three numbers. Okay, 1.99 into 0.74, it comes up to 1.47. Similarly, 1.99 into 0.37, it comes to 0.738 something. Okay, use your calculator and whatever values you get, you write it. And the unit of E will be volt per meter. Because I think you know this already. Okay, E is equal to V by L, right? V is in volts, L is in meters. So volt per meter. So electric field intensity is given, if the unit is volt per meter, or you can apply this SI units, okay, if you don't remember. Now, how to find the magnitude of this vector? It is simple. Take the square root of this value square plus this value square plus this value square. You will get, so this bracket value square plus second value square plus third value square. Okay, what are these? They are these 1.4769 whole square, 0.7384 square, 1.1176 square. Square root of this much will be giving you the magnitude of this vector. Okay, you can see it. I have written here simple electric field intensity in vector. That too, it has AX, AY and AZ directions. But if I check here, you can see magnitude is represented like this. Magnitude is square root of these numbers. Okay, AX direction, AY direction, AZ direction, squares. It comes up to 1.99, approximately 2 volt per meter. Okay, I hope you understood this. Any doubts you can ask me. Now let us take one more problem. Let me tell you, this problem requires some of the basics of your geometry as well as your trigonometry. Okay, so read out the question. Determine the electric field intensity at a point A. Some point is there, that point, at that point we should find the electric field intensity, and that point A, it is located at distances 0.3 meter and 0.4 meter respectively from charges Q1 and Q2. Try to understand. There is a continuity in the question, so you may get confused. Break the question into parts. What we need to do? We need to find the electric field intensity. Where? At point A. Now, where is that at point A? Point A is at distances 0.3 meter and 0.4 meters. From what? From charges Q1 and Q2. Okay. And continuity, there is a question. See here, the question is continued, and charges Q1 and Q2 are spaced 0.5 meters apart. Means distance between Q1 and Q2 is 0.5 meters. And at the last, they have given you what is Q1. It is 1 nanocoulomb. Q2 is 8 nanocoulombs. Both are positive charges. So this is the given question. According to the given question, let us try to put this into a diagram. If I take some point here A, according to the given conditions, it is located at distances 0.3 and 0.4. Assume that this line is of distance 0.3 and this line is of distance 0.4 respectively from charges Q1 and Q2. So अगर आप इसको Q1 करोगे, इसको Q2 consider करोगे, so point A और Q1 के बीच में 0.3 distance है, and point A और Q2 के बीच में 0.4 meters distance है. One more thing is given to you. the 0.5 meters distance indicates the spacing between Q1 and Q2. So ये आपको दिए हैं 0.5. So according to the given question, it can be represented in this diagram. Okay. The diagram shows that it is a right angled triangle. How to decide whether the given triangle is right angled triangle or not? You can apply the Pythagoras theorem. See, 0.3 square plus 0.4 square root if you take, you will get 0.5 hypotenuse. Base and opposite squares, square root of that value will give you the hypotenuse. If this is your hypotenuse, this is your base, this is your opposite. Okay. Opposite square plus base square, square root of that will give you hypotenuse. If you take 0.3 square plus 0.4 square and square root put it, you will get 0.5. That's why I'm telling you it is a right angled triangle. Okay, I hope you understood this, the given question. Here the basics of trigonometry will come. We will further see how we will solve this. As the two different charges are existing, obviously we will be having two different fields, E1 and E2. The net field will be sum of E1 and E2.